Next, we're going to talk about the one-to-one property. So, the one-to-one property of logarithms and exponentials. So, if we're talking about exponentials, we look at something, so if b to the x equals b to the y, so the bases are the same, then that tells us that, I'll write this over here. So then x is equal to y. Because the bases are the same, the exponents have to be the same. Have to be equal to each other. Because essentially that's almost the same thing, equal to each other. For logs, if we have two logs with the same base, log base b of x is equal to log base b of y, same thing. The bases are the same, then x has to equal y. So we're going to use that property to help us solve some equations today. Let's look at our first example here. We're going to look at some log ones. So our first example is going to be log base 7 of 7x plus 3 is equal to log base 7 of 5x plus 9. Well, look at this. So 7 is the base on both of these logs. So that means that they're equal to each other. All we have to do then is set 7x plus 3 equal to 5x plus 9. So I'll move my 5 over. 2x plus 3 equals 9. And then I'll subtract my 3. 2x is equal to 6. So x is equal to 3. And that's it. So these two pieces of the equations have to be equal to each other. Let's try another one. How about one like this? So we've got natural log of 4 plus natural log of x is equal to natural log of 12. So we've got to condense this first to start, actually, so we can have the one-to-one property. This is not the two-to-one property. We have to have one log on each side. So it's important that we condense first. So addition means multiplication. So natural log of 4x equals natural log of 12. Now we have that one-to-one property. This is why it's called that. And we can set 4x equal to 12 and know that x is equal to 3. I promise the answer won't be 3 every time. Let's take a look at let's go some subtraction or division there. Example 3. Log base 3 of x minus log base 3 of 6 is equal to log base 3 of 8. So again, we have two logs on this side and one on the other. We need to condense the left side to make it one-to-one property. So we have log base 3 of, I'm going to write 6x because I prefer, that is not, nope, that's division. So x over 6 is equal to log base 3 of 8. So now I have log base 3, those are the same, and x over 6 is equal to 8. In order to solve this, I need to multiply 6 on both sides because it's being divided. So x is equal to 48. All right, let's get a little crazier. So how about we look at one that looks like this? Let's go example 4. Log of x minus 2 plus log of x plus 3 equals log 14. So again, one log on this side, two logs on the other side. This is common log. That's kind of nice. Just easier, less to write. So I do need to multiply these two together. So log of x minus 2 times x plus 3 is equal to log of 14. If I keep going with this, I'm going to use box method to solve these two. Write this out if you need to. So I have x squared minus 2x, positive 3x minus 6. So I have log of x squared plus x minus 6 is equal to log of 14. Now I have that one-to-one property in place. So I've got logs on both sides. So I have x squared plus x minus 6 is equal to 14. I do need to move this 14 over before I factor. So when I do that, I'll subtract my 14, leaving me with x squared plus x minus 20. So two factors of negative 20 that add and give me a positive 1 are going to be, remember I'm equal to 0 now because I canceled this out. I have x plus 5 and x minus 4. So when I solve this, x is equal to negative 5 and positive 4. It is possible to have two answers if you have two x's.